Hello, Cobb Science. Today we're going to be learning about heat transfer. In particular, we're going to be learning about the concepts of conduction, convection, and radiation.
This water boiling, the heat of the fire, and cooking on the skillet are all examples of heat transfer. In simple terms, heat is the transfer of energy from objects of different temperatures. As objects warm up or cool down, their kinetic energy changes. Kinetic energy is the energy of motion. Temperature is a measure of the average kinetic energy of the particles in an object. As temperature increases, the energy of motion increases. As the water warms up and the temperature increases, you can see an increase in the movement. Heat can be transferred in at least three ways: conduction, convection, and radiation. Conduction is a process in which the transfer of heat takes place between objects by direct contact. It is most often associated with solids. The key to conduction is direct contact. The heat of the pan is transferred to the mini pizzas. The energy of the frying pan is transferred to the eggs. Notice that they are in direct contact. Convection is heat transfer by the movement of a fluid such as air or water when the heated fluid is caused to move away from the source of heat, carrying the energy with it. It occurs due to density. Lava lamps are examples of convection. As the liquid is heated, it rises and falls as it heats and cools. As the paper burns, the air is heated up and begins to rise. The burning paper is swept up in the convection current, cools, and falls back down. These beans are another example of convection. As the beans warm up, they rise and then cool and fall back down, and repeat this over and over again. Radiation heat is transmitted without any physical contact between objects. Watch how the temperature of the lamp is transferred to the thermometer without touching it. These alligators and lizards use radiation from the sun to warm their bodies. If you'd like to know more about heat transfer and conduction, convection, and radiation, this playlist will help. And as always, thanks for watching. And Moo Moo Math uploads a new math and science video every day. Please subscribe and share.
Thank you to Moo Moo Math and Science for allowing us to use that amazing video. Now, we're going to go a little bit more in depth with Paul from Bozeman Science.
Heat is going to be energy transfer when there's going to be a difference in the object's temperatures. In other words, their molecular motion. And so if we have a hot object and a cold object, we're going to see energy transferred from the hot object to the cold object. And how does that occur? Well, it occurs in one of three ways. First way is something called conduction. And so if we have a candle and you want to measure the heat or transfer from some of that heat of the candle to an object, we'll say it's this object right here. In order for it to be conduction, you would actually have to have those objects touching. And so conduction is going to be movement of energy, transfer of energy, when the objects are in direct contact. So if you touch a burner on a stove, that would be conduction. What about convection? Convection is going to be when the heat is transferred through a fluid or through another medium. And so in this case, if the flame is right here, there's air between the flame and our testing device right here. And so some of that heat is going to be transferred. You don't have to necessarily touch the flame in order to feel some of that heat. If you've ever played with a flame at all, if you put the tester above it as opposed to on the side, it's going to be much hotter above it, and that's because we're heating up the air and hot air is going to rise. And so lots of times you'll hear us convection as like a convection current. And so if we have a pot of boiling water on a stove, it's conduction touching to the stove, but then the movement of that fluid up is going to be convection. And then finally we have what's called radiation. Radiation occurs when we have our testing device and it's separated from our heat source using space. And space, remember, is just going to be emptiness or nothingness, so like a vacuum. And so we also have energy that can move from here to here through radiation. We call that electromagnetic radiation. And so what's an example of that? Well, the sun's a great example of that. So where does the energy, most of the energy on our planet come from? It comes from the sun. How does it get here? It gets to us through the emptiness of space. And so we're not directly touching the sun and there's no fluid connecting to us, but radiation can allow it to get here as well. One important thing about radiation is once an object picks up that radiation, it can give off heat in the form of thermal energy as well. And so the heat that we have on our planet was delivered in radiation from the sun, but then it creates heat on our planet.
All right, now we're going to take out our science notebooks. You're going to see several pictures of different forms of heat transfer, and you're going to label whether it's conduction, convection, or radiation. Now that we've learned more about heat transfer, we're going to get to take a look at an experiment about convection. So let's take a look, and keep in mind you're going to get to create an experiment using convection at the end of this video.
With a convection current, you have difference in temperatures. And in this, I have cold represented by blue ice cubes, and then the hot will be represented by the red liquid in this, and it's pretty hot. Not boiling, but pretty hot. So I'm going to place the ice cubes in first, and it should, as it melts, the blue should sink down, and I'll keep that on this side. And then I will place the warm water on the other side, and let's see what happens with the convection currents. Okay, obviously the red is beginning to rise upward, and you can begin to see the blue sink downward. And we'll see if we don't get a convection current going. Okay, now you can see the blue water, which is cold, is sinking down, and the red water, which is warm, is rising up. As the red gets to the top, it will begin to cool and eventually go back down. And if the blue water cools, warms up, then it will rise back up. So as you can see, these are how convection currents are formed.
Now that you've had a chance to see what an experiment with a convective current might look like, you're going to take this opportunity, using everyday household items, to conduct an experiment on convection. Now keep in mind, we have to have appropriate lab safety with this experiment, so don't use any flames and no chemicals. But look around your house, you might find some awesome and easy to use items that you can do to design your experiment.